So in this video here, we're going to build a PDF document Q&A system where we're basically going to combine a lot of different things within the large language model world. So we're going to use a RAG-based system, which is basically retrieval augmented generation, where we're going to use PDF documents that we can then upload, and then we can chat with that as a chatbot, so we can chat with our PDF files. We're both going to use vector databases from Datastax. I'm going to show you how we can set up that whole database. Then we're going to go into a Google Colab Notebook from scratch. We're going to write all of the code to show you how we can connect to the database. Then we're going to see how we can set up our RAG-based system so we can then upload a PDF file and then also connect that to a large language model, which we're going to use OpenAI for. Then we can connect everything and then we can have a chatbot where we can chat with our PDF documents. At the end, we're going to see how we can use a Streamlit application to build a chatbot. So first of all, let's just dive into some of the theory behind these concepts that are introduced. So first of all, let's just talk about the large language models. We are already pretty familiar with those. We take some text, we can take a prompt, we can throw it into our large language models, and they are really good at generating text. So the large language model is basically just for text generation. It is not based on any information unless it's trained on that specific information. But if we're fine-tuning our large language model, it doesn't really have any knowledge. It can connect to like a vector database. It can connect to like Google, Wikipedia, or like whatever resources that you want to use. So as you're probably familiar with large language models, they sometimes just generate some random outputs. They're not factually correct. And again, we don't really need that if you're building like systems on top of that. If we actually want to retrieve some important information, or we want to like connect to our database that has some information and we want to generate correct outputs from our large language model instead of just random generations over time. So our large language models are good for generating text. Then we also have these retrieval-based models. So the retrieval-based models, they're good at taking some input. Could either be like different documents, it could be like web pages, basically just Google. We can take that information, then we can throw it into retrieval-based models, and it is good at extracting this information from the resources that we actually gave into the model. But again, by actually using these retrieval-based models, we can really generate text, and that is the problem with the retrieval-based models. So we have the large language model, they can generate text. We have the retrieval-based models, they're good at extracting information from different files and different resources. So when we're building real-life applications, we actually want something that can take the best from both worlds. And then we can actually combine that into this retrieval augmented generation. You probably have heard about RAG models a lot. This is very popular because this is how we can actually use the large language models to create applications around it. And it is not that complicated to set up, as you're going to see in this video, where we're going to build this whole PDF Q&A document. So we have these retrieval augmented generation models, which can basically take in text, but also extracted information from our retrieval based models. Then we throw it into our RAG model, and then by using that, we can actually go in and generate text based on the information that we have extracted from our resources, and in this case here, from our PDF files. So we can combine all of that, and the last thing that we need to connect to is a vector database. So once we have our data, we have our resources and documents, we want to basically just divide it into different chunks. We want to create embeddings based on that. So often you will use like a neural network for creating embeddings, extracting information. But again, when we're working with large language model systems, we want to have like scalable databases. We want to be able to retrieve our information quickly, but also we want to have these similarity searches, which is why we're using vector databases compared to traditional databases, which you're probably familiar with. So we get our embeddings from our documents that we have actually just embedded. Then we can create these vectors based on our embeddings. And by using these optimization techniques that we can do with vectors, we can then throw those chunks and those vectors into our vector database, which is really scalable and also for retrieving information very fast. And this is how we can combine all of these different kind of components to create large language model systems. This is all the components that you need, and I'm going to show you now how we can do it in code and set everything up. So before we're going to do that, I basically just have like the whole architecture here that we're going to throw in. So we can have our query here, which will be our question to our model, and then we have our index documents, our PDF files, which is extracted into embeddings. We can combine that into our vector store. By using our vector store here, we can go in and search for the specific results in our document based on the prompt. So we basically just embed our query and also our documents so we can create our vector store, generate the search result, throw that into a large language model prompt as you're familiar with, and then we actually get an answer also with the sources. So now we're basing our answers based on factual information and actually like information that we have fed into our system, and also with the specific sources where the model actually like found that information, so we can fact check our models. So we're now jumping into the Datastax website because this is the database that we're going to use to have the Astra database, which is built on top of Apache Cassandra. So that is a really good solution for building generative AI applications and projects around because it's scalable. And again, as we mentioned before, we want to retrieve our data very fast in these specific applications with large language models. So we can basically just get started for free. I'm just going to use a free account for this one here. Then we're going to set up our database, connect to it in a Google Colab Notebook, and then we are ready to build a whole system. So I'm just going to sign up for this free account. So here we can just see some short points: bring the power of real-time data to your next generative AI project. So we can store vector embeddings for generative AI. So this is what we're going to do with our PDF documents: exceptional scalability and robust reliability. And then we can also stream real-time data at scale. So that is why we're using this Astra DB from Datastax. So we're now signed in directly to Datastax. We can see we have all of these different things. We have our databases, streaming, building tokens, and all of it. We also have guides and examples, both for creating like Q&A search with LangChain, Astra DB with OpenAI's Assistance API, and so on. So they have some different guides and examples in here that you can take a look at. But right now, we're basically just going to create a database, and I'm going to show you how we can set that up. So we can both have a vector and a non-vector database, but in this example, as we already talked about, we need this vector database to set up. We have our database name, so let's just call it PDF QA. There we go. Key space name, we can probably just use the same QA name. There we go. We can also specify the provider here. So again, we can either use like Google Cloud, AWS, and also Microsoft Azure. So right now, let's just go with AWS as default. And then we also need to specify the region. And again, we're just going to go with the default one. So right now we can just create the database directly and we don't have to do anything else. We can now see that our database has been created. Right now it is pending. We can both see the health of our database, connect to it, SQL console, settings, and all these different things. We can also go in and see the different regions, the number of requests, read requests, and also write requests. So all of these things are available in here on Datastax. So this is really cool. Again, you can see how easy it is to set up a database. And now we can basically just go in and connect to it with our access token. So we can now see that our vector database is active, and this is basically just running Apache Cassandra. So now we can go up and hit connect. We'll go into this tab. First of all, we need to generate this database administrator token so we can then connect to it within our Google Colab Notebook. And we also need to get this secure connect bundle. So that's everything that we need. And this is all we have to do to set up our database and use it from Datastax. So right now, I'm just going to generate the token. I can then go in and download the token details, which we can upload into our Google Colab Notebook. So again, you can just do the exact same thing. And we also need to get our bundle. Let's go in here. We need to select our region and download our secure bundle, which will download a zip file that we can also upload into our Google Colab Notebook or into our local environment if we're using that. Okay, so let's now jump straight into our Google Colab Notebook. First of all, I've just uploaded both the token, but also the secure connect zip file that we downloaded inside the Datastax website. I've also uploaded this PDF file with Gemini, which is the new large language model from Google. So this is basically the PDF file that we're going to take a look at, and we're going to upload and create this Q&A system around. So this is basically just a paper that we're going to upload. It is 62 pages. So again, this is a relatively large document that we're going to throw into it. We're going to divide it into different chunks, do the embeddings, and then we can do our searches with our retrieval-based models, and then also combine that with OpenAI's large language models to generate responses based on the information and the facts from this paper. So let's now go back here. First of all, we're going to pip install these different kind of modules and libraries that we need. So we have our Cassandra driver, LangChain, OpenAI, PyPDF for extracting our PDF, and then we also have Casio and Tick token. So right now we're just going to set up all our modules. So while it's downloading our modules and frameworks, we can then go and take a look at the Casio documentation. So this is basically for integrating with our Apache Cassandra database. So here it's going to handle all the features and the functionality for basically just dividing it into, doing the similarity searches and so on in our database. And we can use different kind of like adapters and different large language model frameworks. So in this one, we're going to use LangChain, but you can also use Augmented and other libraries. And all of these different things are building on top of Cassandra and can be used directly with Casio. So let's now jump back into our Google Colab Notebook. Now we're going to write all of the code that we need to do to set up our whole system. So right now we're going to import Cassandra. There we go. We should be able to import it after we have installed it. So now we can go in and set up our Cassandra database. So all we have to do is from Cassandra, we need our cluster first of all. So from Cassandra dot cluster, we import a cluster. And this is basically just for setting up our access token and also our secure connect. And then we also need from Cassandra dot authentication dot import. Then we have plain text authorization provider. There we go. We should be able to have all of that. And we also need to import JSON because our access token is in JSON format. So that is, we're going to do that as well. Now we can set up our cloud configuration. So from Datastax, we went into the website, and now we actually just need to connect to all of these different things. So we have our cloud provider, or like our cloud config. That will be equal to a dictionary, where first of all, we're going to have our secure connect bundle. Secure connect bundle. So we have our secure connect bundle. And then we're going to map that to the file that we have over here to the left. We're just going to copy paste that file. There we go. And we should be able to do all of that over here. So we have our secure connect PDF qa.zip. Now we can go down and open our access token with JSON. So here with Python, we're going to open up our JSON file. So let's go in and copy the path. There we go. We might actually need our content as well. So let's just throw that into it as well. There we go. And we're going to open that up as F for our file. And then we can have our secrets. And our secrets will be equal to our JSON.load F. So we're basically just going to load our access token into our secrets variable. Then we need to set up our client ID. Our client ID is equal to our secrets. We can extract all of that from our JSON file. So I'm just going to copy paste that. And then we're going to have our client ID. There we go. And we also need to set up our client secret. And that will be inside our secrets. And that will be. We should be good to go here by having our client ID and also our client's secret. We should be able to extract that from our secrets JSON file. And now we can go down and set up our authentication provider, which we imported up here at the top. So right now we're going to have our auth provider equal to plain text authentication. Then we're going to take our plain text authentication provider. We're going to throw in our client ID. And here we can also see that we need our password will be our client secret. We can set up our cluster. So our cluster will be equal to our create an instance of our cluster that we import up here at the top. So we have our cluster, and here we need to throw in our cloud. So that will be the contact point. So cloud will be equal to our cloud config. And the next argument here will be our authentication provider. And that will be equal to our auth provider that we created up here at the top. So now we should actually have both our authentication provider and also our cluster. We can now go in and create a session that we can connect to. So after we create an instance of our cluster, we can go in and directly do a connection on our cluster. So we can call connect. And now we should actually have everything. Let's just go in and run this and see if that works. We get some warnings, we get some errors, but that's not too big of a problem. But now we can see that it is actually running. So now we should actually have our access token. We should have access to our database or like a Cassandra database. So now we can go down and specify a row. Now we're basically just going to go down and execute a command so we can see that we have connection to our database and we can start using it. So we can call this session.execute and we can select in our database our release version from system.local.1. And if we get a response back, we're basically just going to print our row of index 0. And else, like if we don't get a response back here from our row, we're just going to print error. There we go. We should be good to go. We can execute this on our session and we should be able to see our release version that we pull from our database. So now everything for our database is set up. Our Cassandra database based from Astra DB from Datastax. So now we can go down and set up everything for our LangChain large language model from OpenAI and such, our vector store index, and all of these different things that we went over in the start, and all the different modules that we need to combine this whole system. So now I've just skipped the part where I've just imported a bunch of different modules. So we both need OpenAI embedding, so we can go in and embed our text into different embeddings. We also have our Cassandra vector stores, import Cassandra, vector store index creator. So we're going to create like these vector store indexes for our documents. We need some text splitters and so on if we have two large documents. And then we also need to have our document and text loader and our PyPDF loader from LangChain. So we're going to use LangChain for this specific system. Here we're just going to import the modules, and now we can go down and actually use it. So first of all, here let's just start with our OpenAI API key. So from OS, we're going to set an environment in variable. So environment variable, and then we're going to set our OpenAI key. So OpenAI underscore API key. And then we're going to set that equal to your API key. I'm just going to paste my OpenAI key in here so you guys can't see it, but this is all you need to do. Just go to OpenAI's website, just go inside the API keys, copy paste it, throw it in here, and run this block of code. So now we have our OpenAI key pasted in here. I've run that block of code. So now we can go down and do initialization of our large language models, but also the OpenAI embeddings. So here we're going to set our LLM equal to OpenAI, and then we're going to set temperature equal to 0. So right now we should be able to have our OpenAI large language model, and then we also need our OpenAI embeddings. And we're going to set that equal to OpenAI embeddings. There we go. And we don't need to give it any construction arguments here. We should be able to run it and create an instance of our large language models and also our OpenAI embeddings. Now we can go down and specify our table name that we want to use for our vector database. So here we just have this PDF QA table. And then we also need to specify our key space, which we did inside of Datastax. So here we basically just have our key space equal to PDF QA underscore name. So now we have our key space name here as well. We can go down and create an index creator. So the idea behind what we're doing now is we have our vector store index creator. So basically, if we have a large document, we need to divide it into different chunks, could be like per pages. And then we need to go in and actually create our embeddings with OpenAI based on that. So then we basically just take chunks of our data, chunks of our resources and documents that we want to use for our system. And then we can throw those chunks into embeddings, create these vector embeddings, throw it into our vector database. And then we can scale that very easily, and we can also retrieve the information very fast by using this Cassandra database. So that's what we're doing here. We're going to just set everything up. So we have our vector store index creator. So that's here, and we need some different input arguments for that, as we can see up here at this top. So first of all, we have our vector store class underscore CLS for a class. And here, the class that we're going to use is Cassandra. There we go. The next one is the embeddings, the type of embeddings that we want to use. Of course, there's a bunch of different types of embeddings that we can use, but in this one here, we're just going to use OpenAI's embeddings. So OpenAI underscore embeddings, as we initialized up here at the top. And then we need our text splitter, so text underscore splitter. And we're going to set that equal to a recursive character text splitter. So it's basically just going to split our text recursively based on the characters. Again, we need to divide it into chunks as we already mentioned. And first of all, we need to specify a chunk size. So this will depend on your size of data set and so on. So right now we have, we actually have a pretty large PDF document that we're going to divide into chunks. So here we're going to set our chunk size equal to 400. And we also need a chunk overlap. So how much our windows for our data that we're dividing into chunks is overlapping. So chunk underscore overlap. And we're going to set that equal to 30. So now we should have everything for this one here. And now we can go down and set our vector store key arguments. So we have our vector store underscore KW args, keyword arguments. And then here we're going to have our dictionary. First of all, we have our session. So this is the session that we created previously. And we're going to connect that to our session. We need our key space. And our key space will be equal to our key space variable. There we go. And the last thing is our table name. There we go. Now we should actually have everything. We have our index creator, vector store index creator. We have our Cassandra vector store database that we want to use, the class, OpenAI embeddings, how we want to basically just split our text. And we also have a vector store argument, session, key space, and table name. Let's run it here and see if we get any errors. So there we go. We are able to run that as well. So now we have initialized our large language models. We have initialized our vector store index creator and also our large language models together with our embeddings. So now we can basically just go down and load in our PDF file, throw it through our system, and then we can start actually like retrieving information from that and load in the indexes from our index creator that we just created. So it's just going to do that. So we're going to create a loader with our PyPDF that we imported up previously. So we have this PyPDF loader, and then we're just going to specify the path to our paper that we want to load in. We can have our pages equal to loader dot load and split. So we're basically just going to split all of our PDF, like a whole PDF file, into individual pages, and that's what we're doing here. Let's see if we're able to load it in. So we are able to load it in, and now we're just going to load it and split it by pages. There we go. We can see the length of the pages should be 66, as we also saw in the document. So we can now going to take pages. Let's just going to take page 10, index 10. And here we see all the text that is basically like extracted and also split into these different chunks based on the pages, which we did with this load and split function up here at the top. So basically just have this for all of the pages in our PDF document. And now we can go down and use our basically our index creator to go in and divide it into chunks that we can throw into our vector database. So that's what we're going to do now. So we have our PDF index. That will be equal to our index creator. Like that. And then from loader, then we just need to specify our loader. So this is the loader that we have up here for our PDF document. And now we're going to divide that into different chunks and throw it into our database. So we'll see if we're able to do that. We'll just take a second or two. But now we actually need to set up our default query for accessing our database and just basically just extracting all our information from our table that we're going to set up. So we have our default query. And that is going to be equal to a f string. And then inside of the if string, we're going to have select. So we want to select from, we're going to specify our key space dot table name. So these are the parameters that we set up at the top, or like a previous blocks of code. We should be able to do that. And here we can now specify rows. So the rows will be equal to session, and then we can go and execute a command on our session or a query. So execute dot execute. And then we can throw in our default query. So we're basically just going to select everything from our key space inside of our table name, and then we're going to access that and store it here in our rows variable that we can go in and access for the metadata. So let's just run this here. Let's see if we're actually able to execute this command on our session, and we are. So now we can go down and create a for loop, basically just to show you guys like what's inside of this. We can also just show like a single one, but we can also have a for loop. So for row index, or it could just be I or IDX, comma row in enumerate. And then we're going to enumerate our rows. So we have our individual rows and also our index. So I'm just going to copy paste some print commands here for extracting the information just to save us some time. So we can print the index here, and then we can also print the row ID, embedding vector, the body blob, and also the metadata blob. So this is all the information that we need from our database. So let's just print it here and take a look at it. So if we just scroll up here, we can see the row. So this will be our row in our, basically the rows that we have extracted all our data into. And then we also get our row ID in our database. We get our embedding vector. So we basically take our text from our document, embed it into a vector with the OpenAI embeddings. We can also see our body blob here, data centers. This represents a significant increase in scale. Meta blob here, the page, and also the source where that information came from. So this is all we need. Now we are able to extract all the information from a PDF file, throw it into our database, and now we can build that on top and together with our large language model so we can chat with our PDF files. So now we only need 1 or 2 lines more of code, and then we're able to chat with our documents. So first of all, let's just throw in a query, or we can just say a question. So our question here would be, what types of models are available for Gemini? Question mark, and that will be our question. And now we can go inside our PDF index, and then we can query underscore with sources. Then we're basically going to send our question, and we also need to specify what large language model we want to use. And here in this example, we're just going to use the OpenAI large language model, which we have already created an instance of. Let's throw this in here and see what we actually get back. I haven't tested out this question here before, so let's take a look at it. And then after that, we can dive into the PDF file and actually see if we can come up with some questions, which is actually for that specific document. So here, let's see what type of models are available for Gemini. So the answer here will be returned. There are 3 types of model available for Gemini: Ultra, Pro, and Nano. And we also get this response back here with the sources. So it found this answer and this information that it based the answer on from this source. So let's now just jump into the Gemini paper, and let's go in and fact check the model and see if it is correct. And again, we can see that we have 62 pages. Let's go and take a look at if we can find the actual models. So they should have a table for it somewhere. So here we can see that they have a table. So table 1 here contains an overview over the whole Gemini 1.0 model family. The model sizes, they have Ultra, Pro, and Nano. Let's go and see and just throw in one more question. Let's just copy paste this. So describe, or can you give a description of the Ultra model? Let's throw in Gemini Ultra model. Let's throw it in and see what response we get back. There we go, we get our answer. We also get the source again. So the Gemini Ultra model is a highly capable multi-model model that achieves state-of-the-art results in 30 out of 32 benchmark, including text reasoning and so on. Let's go in and just take a look at the PDF file again. So let's go in and see if it extracted this information from the table that we just took a look at. So Ultra, a most capable model that delivers state-of-the-art performance. So that it has probably combined the response based on this description here, but also some other descriptions throughout this whole paper, which is actually 60 pages. So again, we can see that we actually get a pretty good response. We also get the source back here, and let's just read it through to be able to actually tell if this is correct. So yeah, this answer here is actually pretty correct from the paper. So it's not really just generating random stuff compared to if we were just using standard large language models. And again, if we have standard large language models, they have not been trained on this specific paper. And again, if new information has been released, which it is not trained on the base models, then again, it won't be able to do anything. It won't be able to generate text. It's just going to generate some random outputs, which will not be factually correct. So here, this is how we can create these systems, and this is really powerful and useful for creating real-world applications with large language models. So the next step here is basically just to clean all of this up and create an application around it, and then we're going to see a chatbot created from scratch, where we can throw in PDF documents and have a Q&A with that specific document. Again, we can also throw in different documents. It is not really like training on that. It is just taking all the information, ingesting all that information, extracting the relevant information, and then it's giving answers with our large language models based on that extracted information. So let's not just jump into a Python script. We're going to set up this Streamlit application. We're basically just copy pasted all the code from our Google Colab Notebook that we wrote from scratch. I've just copy pasted all the things in for the database, connecting to the large language models and combining all the different elements, and then just a basic chatbot application with Streamlit. So first of all, I'm just throwing in all the different modules here as we have in a Google Colab Notebook. Then we can create this Datastax connection with our client, and then we can start our Astra session. Then we can go down into our main function, and then we basically just have some different session states that we can set up, both for conversations, messages, and so on. So this is just how we can set up a chatbot with Streamlit. We need to paste in our OpenAI key, create an instance of our large language models, the embeddings and so on, the table name key spaces, our index creator as well. And then we can go down and create a sidebar where we can upload our own PDF file, process that PDF file with our PyPDF loader, load it, and also split it here into a PDF index. If we actually want to activate the chat here, we can throw in a query or like the question that we want to ask our PDF file. So this is how we can do that. So we just have st.chat input. Then we're going to throw that into our large language models with our RAG-based system. Then we get the response back, we get a user, avatar, and also the content, and then we can go in and filter that so we only get the response back, but we also get the resources. And that's everything we have to do here to set up a Streamlit applications with a chatbot for this RAG-based system that we have created, so we can do Q&A with PDF documents that we upload into our web application. So let's not just jump straight down and run our Streamlit application. So Streamlit run, chatbot.py. Then it's going to open up this web interface. So now our Streamlit application is up and running. Over here to the left, we can upload our PDF files. So here I'm just going to drag the Gemini paper into our web application, and now we can hit process. It will then do all the processing as we also did in the Google Colab Notebook. And after that's been processed, we can go in and chat with our PDF and ask it questions, and then we'll get the answers back with the correct information. So now we're going and chat with our PDF. First of all, just ask it again what type of models are available. Question mark, and let's just type it in here. We can see we have this avatar, and then we have our question, and then we'll get the response back. So there's no specific type of model mentioned in the given context. Let's just try to like give it a bit more details. There are Gemini Ultra models available for Gemini. Let's go in and ask it to describe that model. So you can see that Gemini Ultra model is the most capable model and achieves state-of-the-art performance result in 30 out of 32 benchmarks. So again, it's just pulling this information from the PDF file, and now we can go in and chat with our research papers, but it can also be different types of resources that you can basically just throw into a PDF file. You can upload it and then you can chat with it. So this is how we can build these real life applications around large language models that doesn't just generate random stuff, but actually like generate the results based on some information that it has ingested. So that's it for this video here, guys. I hope you have learned a ton. I hope you have learned a lot by going through this notebook, basically just creating this Q&A system for PDF files from scratch. Throw it down in the comment section if you guys have any cool ideas of how we can use these RAG-based models for real life applications. If you want to dive into more details about like how these large language models work under the hood, the transformer architecture and so on, how they're implemented from scratch, like all the way down to the model architecture and the theory behind these transformer models, definitely head into my courses. I have everything. We cover all the theory in details in there. This was more like how we can use it in a practical way, build systems and applications around it for real use cases. So thank you guys for watching this video here. Stay tuned. Until then, bye for now.